In this video, I provide an example for calculating the price elasticity of demand. From the previous videos, we already know the definitions of the price elasticity of demand, epsilon p, which is the percentage change in quantity as a response to a percentage change in price. In the discrete case, continuously, we can also write the derivative of the quantity with respect to the level of the quantity as the percentage change, and the same with the price. Now, this may be a little bit abstract, so we now have a closer look at a concrete example for the linear case of a demand function. Now we suppose that we have a demand function for the particular good that is linear, so that demand as a function of the price is 20 minus 2 times the price. So the level of demand decreases in the price level. The supply function, by contrast, has a positive slope, so supply increases with the price, and we have an intercept of 4 and a slope of 1. So an increase in the price by 1 increases the supply by 1. Then we can calculate the equilibrium price level by setting demand equal to supply, so these two functions equal to each other, which would then be supply here on the left-hand side and demand here on the right-hand side. And this is a function in one variable, p, and we can solve it so that p star, the equilibrium price level at which demand equals supply, would be 16/3, or 5.3 periodically here. And then we can plug in the price level either into the supply function, which is done here, to get the equilibrium quantity, 28 divided by 3, or into the demand function, then we would get 20 minus 2 times 16/3, which would be the same. Then we can just take the formula that we had at the beginning, and we take here the continuous case. So the price elasticity of demand would be the derivative of the quantity divided by quantity divided by the derivative of the price divided by the price. So this is a ratio where we have a ratio in the numerator and the ratio in the denominator, so we can multiply this out, and then we get the price over quantity times the derivative of quantity with respect to the price. Now we know the price level from the previous slide was 16 divided by 3. The quantity in equilibrium, Q, was 28 divided by 3. So that's this expression here. And then we know the demand function itself. That was this expression. So if we take the derivative of quantity, the left-hand side, with respect to the price, we get minus 2. So we have minus 2 here. And if we multiply all these out, we would get a price elasticity of demand of minus 1.14. That would mean that in this case, at the equilibrium price and equilibrium quantity, the demand for this good is elastic. It's negative, so as the price increases, demand for the good decreases, and it's greater than 1 in absolute terms, which means that for a 1% price change, demand would react by more than 1%. Now I show the calculation for the linear case, but in general terms without specific numbers for the price level. And then we would have a demand function where quantity is given by the parameter a, that is the intercept, minus b times the price level. So b, this is negative again, so if the price increases, quantity decreases. So it's the response of the level of demand to the change in price. The supply function S of p has again a constant, that's denoted now by c, and the increase with respect to the price is measured by d. So d is the slope parameter here. Again, we would set supply equal to demand to calculate the equilibrium price level. So we have here the supply curve and here the demand curve. We set them equal to each other and can collect parameters on the right hand side so that we can determine the equilibrium price level as a minus c in the numerator. So that would be this parameter minus this parameter, so the two intercepts, divided by b plus d, so the two slopes. That would be the equilibrium price level p star at which supply is equal to demand. And then we can plug this back into either the supply function or the demand function to get the equilibrium quantity. So if we plug it into supply, we get C plus D times A minus C divided by B plus D. And if we plug it into demand, we get the corresponding expression here. Well, and then we can again use the formula for the price elasticity of demand. We use the continuous case again, where epsilon P would then be the price level over the quantity. If we take these numbers from the previous slide, we get for the price A minus C over B plus D. So that's the numerator here. For the quantity, we get from the previous slide C plus D times A minus C divided by B plus D. And finally, we need to have the derivative of quantity with respect to the price that we get from the demand function directly. So the derivative of this with respect to P is equal to minus B. So the elasticity, the price elasticity of demand in this case would be this expression, which are all parameters. So we can just plug in the corresponding numbers if we have a particular case and then calculate the number that is associated with the price elasticity of demand. Thank you very much for watching the video, and I hope you found it interesting and useful. For more videos on economic content, please visit my channel that you find here to the left. And to the right, you see the next video in the series at the top, and at the bottom, you see the whole lecture in the form of a playlist.